Okay, can you see my slide?
Yes.
Yes, madam.
Boleh, madam.
Okay, so today we're gonna discuss about chapter 9. Chapter 9 is panjang juga sikit. Tapi this chapter is very basic, very good, fundamental, especially you are electrical student. So this chapter is very good introduction to other subject lah when you embark into part 2 and so on lah. Okay, so for this subject we have 11 chapters. So after we cover this chapter, kita ada 2 minggu lagi to cover for chapter 10 and also chapter 11. Okay, we go through this chapter. Agak panjang juga, ada around 60 slide. Okay. Okay, so we're gonna learn about direct current and AC current. Kita akan belajar pasal DC current and AC current. But for this week, kita akan cover DC current dulu. AC next week sebab dia agak panjang. Okay? So what we gonna learn in the direct current adalah we gonna have 7 subtopic. Subtopic 9.1 until 9.7. Okay, so this is the lesson outcome. So we hope at the end of this lesson, students should be able to define and also can calculate. Okay, kita go one by one lah. Okay, we have a direct current. Direct current ataupun in short term usually we use DC. Okay, what means by direct current is actually it has a constant direction. If the current in the constant direction, for example, here we have a battery here. We have a positive polarity and negative polarity. So we can see the current flow from the positive terminal to the negative terminal. So this current in this circuit flow from the positive terminal to the negative terminal. So dia constant. Dia tak ada berlaku from negative to positive. So this is not happen. So automatic this one we consider is a DC current. Constant direction. Okay. Okay, what means by the electrical current? Okay, the symbol for electrical current is I. And the unit of I is ampere. Ampere ni actually a name a person who come up with this theory. So dia letak nama dia lah, Mak Saleh lah. A scientist that come up with this theory. So dia letak nama dia ampere. So if you also come up with a theory, you boleh letak nama you lah. But make sure the theory is proven lah, terbukti betul lah. Okay, ampere. So the unit dia A lah. So current is one of the SI unit standard unit yang kita belajar dalam chapter 1 Okay, so I equal to Q over T. I current equal to the numbers of charge in certain time. So I is actually a net amount, a total of a charge. Charge is Q passed through the wire per time T. Okay, so I equal to Q over T, and the unit is ampere. Okay, here we this figure shows how we gonna complete a circuit. So katakanlah we want to light up this bulb. We want to switch on this bulb. So this lamp on. So we have to make sure we complete the circuit. So from the negative to from the positive polarity to the negative. So there are current flow to this bulb. That's why bulb menyala. Katalah let's say there are the wire is broken, putus. Tak ada. So what happened to this bulb? On ke off?
Off.
So ini kita this one we call open circuit. Open circuit. So if the circuit is not complete, so there are no current flow. Okay. Okay. Example 9.1. Can you determine which figure that the bulb will be on? Is it figure A, figure B, or figure C? Which one?
Figure C. Figure C.
Yes, good. So the figure C shows the complete circuit. So for the figure A, the bulb will be off, and also for figure B, the bulb will be off, because dia hanya sambung kepada negatif to positif to positif. So positif, sini pun positif. This one sambung pada satu saja. So there are the circuit is not complete. This one complete. From positive to the positive terminal of mental lamp bulb, and then continue to the negative polarity of battery. Okay. So current kita define dia akan flow from positive to the negative polarity, from positive to negative polarity. But actually what happened is electron dia opposite direction. So we learn in the theory, we learn in the subject, the current I flow from the positive to the negative. But actually electron is in this wire flow from the negative to positive. Sebenarnya electron, charge electron, so katakanlah ada atom, ada material, ada charge electron. Actually this the movement of this electron, the flow of this electron lah that generate the current. Okay. Okay, so the electron flow from the negative to positive. Okay. Okay, this figure shows how actually what happened how to trigger the electron how to trigger the movement of electron. Okay, so let's say this is a wire, kan, wire-wire apa-apalah, wire charging phone ke, wire-wire iron ke apa-apa, any electrical device. Okay, so ini dalam wire dia. So what happen is dalam wire ni ada kita pakai conductor kan, conductor. Dalam wire ni ada elektron. So ada elektron. So without you, kalau wire ni you tak sambung apa-apa power supply, so the electron in this wire dia free electron tapi dia move not in synchronized moving. Dia ada bergerak ke sana, ke atas, mungkin elektron ni bergerak ke bawah, ke atas, ke kiri, ke kanan. So because of the each electron moving not a standard path, bukan dalam satu flow yang sama, so there are no electric flow in this wire. So tak ada current lah mengalir. But if we connected this wire to a certain power supply such as battery, positive minus, what happen is the electron will attract to the positive polarity because the electron is negative kan. So bila dia jumpa, dia nampak positive electric, it will attract. So dia akan, all the electron in this wire, dia akan flow to the same direction. So that's why inilah yang the phenomena that produce current, generate current. Okay? So mesti ada power supply baru you can produce the current flow. So kalau setakat wire, setakat metal biasa, without any power supply, there are no current flow into the go through the wire. Okay? Okay, kita tengok example 9.1 some how to calculate, how to solve this question. Okay, let's say the current in the wire is 0.6 ampere. So this is I. How much charge flow through a point? Charge is a Q. In wire in 5 seconds. So this is T. So we know I equal to Q over T. But this one given, this one given, we want to find the Q. So Q equal to I times T. So 0.6 times 5, you will get the 3. So the unit for charge is a column. Column. Ni column ni pun sebab column ni pun sebab a person that come out with this discovery, this theory pun nama dia column. So that's why unit dia ni. Okay? Okay, lepas tu dia tanya how many electron pass the point in 5 seconds. So dia nak tanya berapa elektron pass the point. Dia nak tahu berapa E. Okay, so kita boleh, okay, kita tahu satu kolom sama dengan 1.602 times negative times 10 power of negative 19. So kita bahagi sajalah 3 bahagi. So kalau kita ada 3 kolom, so berapa ni? So kita bahagi sajalah 3 column divided by 1.60 times 10 power of negative 9. So ini yang berlaku. So we have 1.873 times 10 power of 19 electron. So kita ada berbilion-bilion elektron that flow to this wire, flow through this wire in 5 second, 5 saat saja pun kita dah ada berjuta-juta elektron. Okay? Okay, for exercise 9.1 you boleh buat sendiri. Okay, now we move to the Ohm's law. So untuk soalan tadi, ingat saja formula I equal to Q over A. So this is the first formula that you have to know and you have to memorize. Okay, now we go to the Ohm's law. Okay, again Ohm's law ni pun sebenarnya nama a scientist that come up with this theory lah. Saya lupa nama dia apa, but it put his name in this law. Okay, so this law state is V equal to IR. So this is the second formula that you have to know. V equal to IR. V equal to IR. V is the voltage. V is the voltage. I is the current. R is the resistance. V is the voltage ataupun kita panggil potential difference. Okay, R is the resistance. R is the resistance of the material. Okay, ingat this is a second formula you have to know. Okay, so kita ada ohmic conductor. So, okay. This graph follow the Ohm theory, which is V equal to IR. So if we sketch a graph that I versus V, so dia punya slope ni adalah I over R. Ataupun kita boleh, biasa kita lukis graph V versus I. So kita akan dapat straight line juga. Okay, the slope ni, when you calculate the slope, kecurunan slope ni equal to R. Okay, ini adalah non-ohmic conductor. Maknanya ini bukan conductor lah. So kita biasa material, kita ada 3 jenis lah. Satu conductor, satu insulator, satu semiconductor, separuh conductor. Conductor ni macam contoh wire, macam copper, aluminium. Kalau insulator ni macam rubber, getah, plastik. Okay, semiconductor ni dia macam apa tu, diode, LED and so on. Okay. Okay. So for this for Ohm theory, you kena ingat V equal to IR. So this is second formula. Okay, we move to the resistance and the resistivity. Okay, resistance ataupun the short term is R. So kita tahu tadi V equal to IR. So kalau kita R, kita manipulate this formula, we get R equal to V over I. Okay, so tak perlulah ingat formula ni, ingat yang formula tadi saja. Okay. Okay, untuk resistor, the unit are ohm. The unit are ohm. Okay, this is example of resistor. So if you doing a lab in the any lab, so kita biasa pakai resistor ni lah. Kita panggil apa nama resistor ni? Okay, this resistor, how to indicate the value of this resistor is based on the color code. So kalau kita tengok resistor ni, dia ada color code on the apa tu, that color on the material itself lah. So how to know this value is based on this color code lah. So this one, I'm not going details. This one you will gonna learn in electrotech. You want je electrotech? Ada kan?
Ada.
Okay.
Ada.
So ada satu eksperimen yang pakai ini kan. Okay. So ni how to measure, how to read color code. So the number, each color indicate different value lah. Because I'm not going details on that one. Okay, this is example 9.3. Okay, a hair dryer draws 15 amps when plugged into a 210 volt line. So this is I, this is V. So what is the resistance R? So use the second formula. We know that V equal to IR, but the question asks you to find R, so we manipulate the formula, so we get V over I. So 210 divided by 15 ampere, so we get 14 ohm. Okay. Okay, we have exercise 9.2. You can do by yourself. But if you have any problem, you just ask me. Okay, now we go to the resistivity. Resistivity is the material property. Okay, so this is the third formula that you have to know. So the resistivity equal to R times A times I. I is the current, R is the resistance, A is the area. Okay, resistivity is the resistance of wire is directly proportional to length and inversely proportional to cross-section area. So the resistivity ni so kalau wire tu lagi besar, lagi tinggilah the resistivity. Tapi kalau dia ni dia punya length, ini area luas kabel tu. Okay, so resistivity lagi tinggi kalau area tu lagi luas. Tapi dia inverse proportional dengan length. So kalau length tu lagi tinggi, resistivity makin kurang. Okay, so this is the third formula that you have to know. Okay, so tadi kita ada resistivity, sekarang kita ada conductivity. So conductivity sebenarnya opposite of the resistivity. So kalau resistivity the unit is rho, for conductivity unit dia gini unit dia macam ni. So how to measure the conductivity? You just 1 over rho. So this is the fourth formula that you have to know. Okay, ini contoh-contoh resistivity for different material. We have silver, copper, gold. So you can see here. aluminium and so on lah. So kalau you tengok kat sini hard rubber yang paling tinggi resistivity dia. Resistivity ni macam halangan untuk the current flow lah. So kalau rubber getah memang paling bagus sebagai insulator, sebagai penebak. Sebab current memang susah nak flow this through the rubber material because the resistivity is very high. Okay. Okay, ini example how to calculate the resistivity. Okay, the resistivity of silver wire with a radius, ini R, is, okay, ini adalah resistivity. Okay, ini adalah L. So, what is the resistance of the wire? So, kita ingat tadi, formula dia tadi, rho equal to RA times L. So, yang ni given, yang ni given, yang ni given R. We want to know R lah. So, R equal to resistivity times L divided by A. So, masukkan dalam formula. So, this is the answer, 5.98 times 10 power of negative 2 ohm. Okay, other exercise question you can answer. Okay, so now we must we move on to the resistor in series and parallel. This one also you doing the experiment in Electrotech. Saya rasa ada this series and for parallel. Okay, this is example of series circuit. Okay, series. Okay, for current kita ada dua jenis. Satu kita panggil the first one we call a series, another one we call a parallel. Okay, so how do you know this is series or parallel? It's based on the position of the load. For example, here we can see the R1, R2 and R3. You put a side by side. So R1 is connected to R2 and R3 is connected to R2. You put side by side, so automatically it will consider as a series circuit. So for series circuit, the current is equal. So the current flow through I1 through resistor 1 equal to current flow to resistor 2 and equal to the current flow through the resistor 3. Okay. Ataupun we can simplify this circuit into this equivalent circuit lah. So R equivalent is actually R1 plus R2 plus R3. Okay, so that is the series circuit. So for series circuit, current equal I1 equal to I2 equal to I3. But the voltage here is equal to V1 plus V2 plus V3. Okay? Okay, this is example 9.5. Okay, R equivalent. So equal to 4 plus 2 plus 6. So we get 12 ohm. I total. So I total equal to, we know that V equal to I R. So I equal to V over R. So I equal to V adalah 6. R total, R equivalent is 12. So we get 0.5 ampere. Okay, voltage drop across each resistor. So we want to know what is the V1 here, what is the V2 here, and what is the V3 here. So we can use the same formula, which is V equal to I R. So I kita dapat 0.5. But R for V1 is 4. So kita akan dapat 2 volt. Ini 1 volt dan sini 3 volt. So 3 volt plus 1 volt plus 2 volt equivalent to 6 volt. So 6 actually 3 plus 1 plus 2 lah. Sebab kita tahu V total V1 plus V2 plus V3. Okay, so this is for series circuit. Okay, now we move to the parallel circuit. Okay, so parallel circuit. So you can see here the position of each resistor in a parallel position. So the point R1 sambung dekat point R2, sambung dekat point R3. And other point of R1 connected to other point of R2, connected to the point of R3. So ini yang kita panggil parallel circuit. Okay, for parallel circuit, the current total is I1 plus I2 plus I3. But the voltage V3, V2 and V1 is equal. So V equal to V total equal to V1 equal to V2 equal to V3. Okay, but for resistor equivalent is 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so this is the conclusion that the difference between series circuit and parallel circuit lah. So yang ni sajalah. Okay, so this is the formula you have to know. Okay, this is example 6.1. Okay, boleh buatlah nanti. Okay, setakat ini can we continue 5-minute breaks? Everyone? Boleh? Okay.
Boleh.
Nak continue ke nak ni?
Break dulu.
Break.
Okay, kita break 2 or 3 minutes. Okay, kita break dulu sekejap. Kita minum air ke apa?
Alright, madam. Thank
Madam.
you.
Okay.
Thank you, madam.
Madam, nak tanya boleh?
Boleh?
Tak, ni bukan pasal Fizik ni dan ni pasal yang lain ni. Yang link untuk bantuan komputer tu masih buka lagi tak?
Nanti saya tanya kepada agensi yang terlibat. Boleh saya tanyakan.
Okey.
Sebab dia ada limited laptop, nanti saya tanya AJK dia. Okay, nanti you WhatsApp saya lah. Okay?
Okey.
Okay, saya Okay, can we continue? Ada sikit je lagi
Boleh, boleh.
Boleh.
Boleh habiskan. Memang chapter ni agak panjang. So ini part 1 lah. Next week kita akan masuk part 2. Okay, so electrical energy and electrical power. So this is electrical energy and electrical power. Okay, so the figure shows the closed circuit. So we have a bulb here. Bulb ni nyala lah. So kita ada point P and we have a point Q. So we can define here that the potential of the point P is higher than the potential of Q. The potential, the electric potential of P is higher than Q. Electrical potential P higher than Q. That's why the current flow from P ke Q. That's why bila ada current flow, bulb ni on Macam contohnya macam ni lah. You ada air. So air akan mengalir kepada tempat yang lagi rendah lah. So bila mengalir tu, itulah yang berlaku flow lah, current flow. So that's why the bulb is on. Okay, so the potential difference V, kita boleh cari, tadi kita cari V equal to IR. So kita boleh juga guna satu formula lagi, iaitu energy dissipated over charge. Energy dissipated over charge. V equal to E over Q. Ataupun kita manipulate the formula is E equal to QV lah. QV. But we know Q tadi, Q equal to IT. So ITV. So ini Okay. So ini energy dissipated. Energy dissipated. Okay, so we have another term. Kita panggil dia power. Electrical power. So electrical power ni lah yang selalunya bila kita beli barang kan, kita tengok berapa power dia, ataupun when we want to pay the electrical bill kat TMB, so dia tengok electrical power ni lah. So the formula for electrical power is P equal to IV. So highlight this formula, P equal to IV. Ataupun kita boleh guna this formula lah, but this formula is actually derived from the P equal to IV, tapi pada masa sama kita tahu V equal to IR. So kita boleh manipulate these two formula, kita dapat this formula lah. Okay, the unit of P is watt. W. Watt ni pun James Watt nama dia. James Watt. James Watt ni lah yang come up with this finding. Sebab tu dia letak nama dia. Ataupun kita boleh guna joule per second. Okay. Okay, so bila you bayar bill, actually bukan power, adalah energy power consumption multiplied by the time. So bila you bayar bill sebenarnya bukan you bayar untuk P tu, tapi power times T lah, masa dia. So itu yang Dan unit dia dalam kilowatt per hours. Kilowatt hours. Okey, itu power. Okey, contohnya kita ada bulb V 3 volt, current dia 0.4. So we know P equal to IV. So you substitute the value, you get 1.2 watt. Okay, itu example you boleh buat nanti later. Okay, we go to the last topic, EMF and terminal voltage. Okay, kita belajar chapter ni, kita belajar pasal direct current. Direct current is a constant direction, one direction only. So, if the potential difference between terminal of battery is constant, potential difference between two terminal of battery, okay, setelah kita ada battery plus minus, so the potential difference between this battery is constant, so kita panggil EMF. So the battery is known as source of EMF. What EMF? EMF is electromotive force. Okay, the motive force ataupun EMF, simbol dia macam nombor 3 tapi terbalik. The maximum possible voltage that the battery can provide between its terminal. Itu yang kita panggil EMF. Okay, katakanlah you beli bateri kan. Bateri 3 volt. So dia punya EMF tu 3 volt lah. The maximum possible voltage the battery can provide between its terminal. Tapi lama-lama bila you guna bateri ni, lama-lama dia akan dia akan menurun dah the voltage tu kan. So EMF dia adalah 3 volt. Okay. Okay, so the EMF source is equivalent to the open circuit voltage. So waktu circuit ni tak sambung pada apa-apa lagi, tak sambung kepada bulb ke tak sambung. Waktu asal tu, waktu open circuit, itulah yang kita panggil EMF. Okay. So contoh EMF adalah macam bateri, electrical generator, apa-apa saja yang produce direct current, kita boleh panggil dia adalah source of EMF. Okay. Okay, the unit of EMF is a volt ataupun joule per coulomb. Biasa kita pakai volt lah. Okay, contohnya bateri, dry cell, electrical generator and solar cell. Okay, ini contoh EMF lah. Okay, ini kita ada letak switch kat sini Kita ada letak switch. Okay, pada waktu initial condition, switch ni terbuka Switch ni terbuka. Maknanya ni voltmeter Voltmeter adalah measure the voltage across a certain point. So bila waktu ni terbuka, maknanya resistor R ni tak bersambung lah. Tak bersambung. So the voltmeter only measure the voltage across the power supply lah. Okay. Tapi bila we the second condition kita close this the switch, so what happen is current also flow to the this resistor. So current ni akan flow to the via the resistor lah. So bila kita baca, kita akan dapati voltage ada voltage drop dekat volt ni. Katakanlah sini 12 volt. So mula-mula kita baca 12 volt lah. Tapi bila kita sambung kepada internal resistance, sepatutnya kita baca 12 volt jugalah sebab dia parallel. But what in the real condition ada voltage drop sedikit. Why? Because dekat power supply ni pun ada internal resistance. Sebab tu ada voltage drop sedikit. Kita panggil the internal resistance. The battery itself has some resistance. So kita tak akan dapat 12 volt. Mungkin ada mungkin 11.91 volt. Maknanya 0.01 tu dia hilang ke mana? Hilang kepada the internal resistance. Okay, so saya tak nak go details lah yang ni. Okay, itu beza antara electromotive force dengan potential difference. So electromotive force ataupun EMF ni biasa dia akan lagi besar daripada voltage. Sebab electromotive force ni waktu open circuit. So waktu bateri tu tak sambung apa-apa lagi, you sambung terus kepada voltmeter. So mungkin dapat bateri 12 volt, dapat 12 volt lah kat sini. Tapi bila bateri ni you sambung kepada load ataupun bulb. So voltmeter kat sini mungkin tak baca dah 12 volt, mungkin dia akan baca 11.99. So mana lagi 0.01 hilang? Sebab dalam bateri ni juga ada resistance tersendiri ni. Internal resistance. Okay? Okay, itu saja chapter. Bawah ni adalah summary lah. Boleh go through all the summary below. Okay, ada soalan apa-apa? Any question for this topic? Pukul 3:30 lah. Jam lah buat ni. Ya Allah. Any question? Minggu ni kita tak buat lab lagi sebab lab yang lab 3 tu berkaitan dengan chapter ni lah. Ada DC dengan AC, so tak boleh buat lab lagi lah. Okay. Ada apa-apa soalan? Ada soalan?
So far tak ada, madam.
Okay. So saya rasa setakat itulah
Tapi kalau apa-apa saya WhatsApp madam lah. Nanti saya tanya.
Boleh insyaAllah.
Saya pun WhatsApp madam dulu.
Mesti madam.
Cuma kadang-kadang saya ni reply lambat, tapi insyaAllah kalau you WhatsApp, lepas tu kalau ni you WhatsApp sekali lagi. Jangan risau kalau saya tak reply.
Thank you.
Lupa. Okay, saya rasa itu saja for our class today. So insyaAllah kita akan continue this another chapter lah, AC, sebab kita masuk lagi AC. Part 2 punya next week. Okay.
Okay, madam.
Okay, thank you.
Thank you.
Thank you, madam. Assalamualaikum.
Thank you, madam. Thank you, madam. Thank you, madam.
Thank you, madam.
Sama-sama.
Hi guys.